Hello, welcome to another Lawrence Academy screencast. Today we're going to be talking about translating quadratic functions. And in order to do that, we're going to have to do a little bit of review. If you can recall, a little bit earlier in the year, we studied translating absolute value functions. So here we have the absolute value equation, f of x equals the absolute value of x. We can see the parent function here. And recall that as far as translations are concerned, we basically have three different types to work with. We have the horizontal shift, which is of course left or right. We have the vertical shift, up or down. And lastly, we have the reflection over the x-axis. So let's take a look at a couple of these different problems. So the first problem I want us to take a look at is right here, is the horizontal shift of f of x equals the absolute value of x plus 1. And I chose to do the plus 1 because this is the one that's counterintuitive. So as we recall, it looks like it would be a shift to the right one, but in actuality, it's the opposite, and it's a shift to the left one. So here is our first translation. We're taking our parent function and we're shifting it to the left one. So that is a horizontal shift. Now let's take a look at a vertical shift, which is up or down. I'm going to move the parent function back here to the origin, and let's take a look at the equation f of x equals the absolute value of x plus 1. So in this case, rather than moving the graph to the right or the left, we're going to shift this up or down. So if we see a positive on the outside, right, that means we're going to shift it up. If we were dealing with f of x equals the absolute value of x minus 1, then this would be a shift down. So from the parent function here, the absolute value of x minus 1, and we're shifting down. Now the last translation that we have to talk about is going to be the reflection over the x-axis. And this occurs when there is a negative sign outside the absolute value. So the equation itself is going to look like this. And there's not going to be any shift to this, the parent function as far as left or right or up or down. All we're going to do is we're going to flip it upside down. So see how we have that V-shaped opening up? When we use a reflection over the x-axis, it's going to be an upside down V opening down. And it's going to look like this. I will do my absolute best to draw this as neatly as I can. There you have it. So the reason why I went into such detail to review this is because when we're doing the translations of the quadratic functions, it works literally the exact same way. The only difference is that the shape of the graph is going to be a little bit different. So let's take a look. So here we have our parent function f of x equals x squared. All right, so notice the shape of this graph is different than the absolute value, right? This is called a parabola and is more curved or U-shaped. So now we are going to take a look at a horizontal shift. All right, so let's see the equation f of x equals x plus 1 squared. And we assume, based on what we've learned from the absolute value functions, that this would be a horizontal shift to the left one. Let's take a look. So here we can see that the graph has been shifted to the left one and otherwise has the same shape. Vertical shifts and reflections will work exactly the same way. So here, try a couple on your own. Best of luck to you.